On here, and today I'm going to help you to figure out if you have a marble or any other projectile launched at a specific angle with a specific speed. How do you find the x and the y components of that? So what I want you to imagine is we got our marble launcher. There's our marble launcher, and we have our marble that was launched out of it. Okay, there's the little swoosh lines because it's being launched. And what I want you to do is I want you to draw an X and a Y graph that the marble is centered on the origin. So here's your Y-axis, here's your X-axis. And then I want you to try to draw as best you can what a 75-degree angle would look like. Now keep in mind, straight up and down is 90 degrees, and straight to the side is 0 degrees. So where would 75 be? It's going to be closer to the 90 than it is to the 0. And draw it as an arrow. Okay, so here's my 75 degrees. Now, scientists very quickly realized that they could make a pretend triangle out of this. So if you go from the tip of the arrow and go straight down until you hit the x-axis, and then if you follow the x-axis all the way back to the origin, notice you have created a right triangle where that little square there represents a 90-degree angle. And the length of this side here is 3.5. And where did I get that number? That was my original speed. Okay, now I realize that's not a length. 3.5 m/s is a speed, but we can use the same principle here to figure out how much of the speed is up and down and side to side. Now, let's label some things. This side here is our hypotenuse, right? The side of the triangle that's opposite of the angle is what we call the opposite side. And the side of the triangle that is touching or adjacent to the angle is what we call the adjacent side. Okay? And all of this then comes down to us being able to use SOH CAH TOA to figure out how much of our speed is up and down, which we're going to call the VY. The up and down side of our triangle helps us to figure out how much of our speed is up and down. And the side to side triangle helps us to figure out side to side, which we're going to call Vx. Y for up and down and X for side to side. V because it's a velocity. Okay, so let's look at this. How do we solve it? Well, let's focus on the Vy first. What part of SOH CAH TOA is talking about opposite? Well, that's the SOH. Remember, S stands for sine of our angle equals O stands for opposite, and the H is always going to be divided by the H is hypotenuse. Right? Well, for this one, we're going to replace, instead of have opposite, we're going to have Vy. Instead of hypotenuse, we're going to have our 3.5. So let's do that. Sine of our angle, theta, that's the symbol for theta. We call that a theta. It's a Greek letter. That gets replaced by the number for our angle, so 75. Sine of 75 equals, I'm going to keep this as a Vy, just to remind myself it's a velocity, divided by the hypotenuse, which is 3.5. Okay? Got to do a little algebra. You got to multiply both sides by 3.5 so we can get rid of that and get the Vy all by itself. But you'll end up then with Vy equals 3.5 times sine 75. And when you plug that into your calculator, be careful here, order is important. Okay? Sine of 75, get that answer, multiply it by 3.5, or 3.5, multiply that by sine of 75. If your calculator is in degrees mode, it should give you the right answer. Make sure your calculator is in degrees mode, not radians. Then you need to get this answer here. Round to 2 or 3 decimal places, 3.38 if you round to 2, and then look at your units. Go back to the original question. What were the units on the question? Meters over seconds. So that would be your Vy. Now we do the same thing for Vx. Except Vx here now is talking about adjacent. So we go back to SOH CAH TOA. What part of SOH CAH TOA is talking about the adjacent side of the triangle? Well, that's the CA. C stands for cosine of our angle, theta, equals the adjacent side, A, stands for adjacent, divided by, and H stands for hypotenuse. Remember, if you don't remember these equations, they're on your equation sheet. Okay, so you really don't have any excuse there. Just make sure you remember they're on the equation sheet. So we're going to do this again. Cosine, the angle is still the same one, 75, equals our adjacent side. We're going to use Vx for the adjacent, divided by our hypotenuse, which is still that same 3.5. So again, I got to do a little algebra here to get the Vx by itself. That'll cross off. I forgot to cross it off up here. I'll do that real quick. So Vx is going to equal 3.5 times cosine of 75. When I plug that into my calculator, I get 0.91. And again, the units on this are meters over seconds. So that's how you find the x and the y component for a projectile.